All right, so 1.7, solving linear systems using matrices. So now that we've learned how to write matrices or a matrix, now we're going to show you how you put it in a calculator, how you put it in an app to solve it. So the first thing I'm going to do is, you notice they give you a big system, same thing as like in the warm-up or whatever. I'm going to write out the steps of what we're going to do if we use a calculator, how to do this. So just over here, kind of in this big column here, I'm going to write out what exactly you got to do in order to make this happen. Sorry, that's a P. Steps. All right, so step one, you need to write the matrix. So that's going to be going through all your steps of what we've done before, getting everything in standard form, etc. So I'm just going to say write the matrix. And again, in that step, you're making sure it's in standard form, all the stuff we learned last section. So now, here's where it all is in your calculator. So we're going to press, and anytime it's a button in the calculator, I put a box around it. So you're going to put second, and then the X inverse key, which is the key with the X -1. And again, we're going to write all this out, then we're going to actually do it. So it is kind of a lot of button presses, but this is one of these things that once you've done it, it becomes kind of second nature. That's the whole purpose of today, is for you to practice it a little bit and make sure you're good with it. All right, so then from there, we are going to pick the edit option. We're going to arrow over, and we're going to input the matrix. So whatever our matrix is from the problem, we're going to type it in. Okay, step 4, we're going to press second mode. That quits us out of the app, or out of the program, I guess, not really an app there. Then step 5 is the same as step 2. We go back into the matrix menu. And then we pick the math option. And you want to pick the one that says RREF with a little parenthesis. Now, if you remember that from Friday, that stands for reduced row echelon form. Essentially, it means it's going to solve, you're telling the calculator, hey, I want you to solve this matrix. I want you to reduce everything down to single variables. Again, this looks really complicated because we're just writing down all the steps. Once you start doing it, it makes a lot more sense. Then the final step is you're going to press second. You're going to press the matrix button again, the X -1. You're going to pick matrix A, and then you're going to press enter. So again, I'm just writing this down so you have it to look at, essentially, if you need to. But again, after you've done this a few times, you're going to feel pretty comfortable. You're not going to keep referencing this. But this, for today, when you do, it's available for you. All right, so let's go ahead and do this for this first problem. So the first problem is getting the matrix in standard form, getting it written, getting it to look how it's supposed to look. So same thing as we did in the warm-up. We want to get everything in standard form here. So the first line is going to be X minus Y. We also need to minus the Z over. So that one's going to be equal to 0, which is fine. 0 is a number 2. This one here is already in standard form. So 4X plus 3Y plus 2Z equals 6. Looking good. Here you got to flip your X and your Y around. So it's going to be -X plus 2Y minus 3Z equals 13. All right, so cool. We can write that as a matrix, so we'll be able to input it in our calculator. That's going to be 1, -1, -1, 0. 4, 3, 2, 6. -1, 2, -3, 13. All right, so we've got that all set up, ready to be put in the calculator. So that's kind of the first, that's the only real work you have to do. Everything else from here is done in the calculator, and then it's going to output your solution to this. Okay, so we're going to follow our steps, and then we're going to input the matrix. So I'll kind of leave them there as we go. So we've got the matrix written. So second X inverse, if you look at your calculator, you'll notice it says matrix right above X inverse right there. That's why we're pressing second beforehand. So basically, we're going to open up the matrix menu. Actually, just so we don't have any weird issues, let's have everybody just reset first. So before we do any of that, do second plus 7, 1, 2. That way we're all base, nothing's in your calculator. I would actually recommend anytime you want to clear your matrix, that's the best way to clear it out. There is another way to clear it out, but it's a lot of random things you got to remember. Just resetting the calculator, very good move. Okay, so anyway, back to the matrix menu. So second X inverse. So now we're done on step 2. So now we're going to go over to the edit option. So that's right here. So just arrow over. And you're going to pick this matrix A. And this is where we're now going to input whatever our matrix is. So let me slide over. So you'll notice whenever you have a matrix, it's going to say it's a what by what matrix. And it's basically saying how many rows by how many columns. So this has 3 rows and it has 4 columns. So this is going to be a 3 by 4 matrix. Now, if you don't remember that and you're like, well, I don't know if it's 3 or 4, then you just type it in and you look and you're like, oh yeah, this matches what I've got. If I arrow over, I see I have 3 and 3. I've got 4 columns that I can use if I arrow over. So, if you don't remember which is which, just put it in and you'll see. So now we can enter these in. So you just got to type the number, press enter, and you'll notice then it just jumps over. So -1, -1, 0, and it'll go all the way across and then it'll jump down. So you can really just do it by just literally just pressing enter. So 4, 3, 2, 6. There's my second row. -1 to -3, 13. I would strongly recommend arrowing around and double checking these. So, because if you mistype one of these, you're going to get the wrong answer in the end. So you want to be careful, take your time, make sure you don't miss a negative, all that kind of stuff. Be cautious when you're doing this. So, all right, so we've got it all in there. We're looking good. So now what's our next step? This is the one that most people forget to do. From here, we need to get out of this. So second mode, if you notice, mode is right here. Second mode says quit. So you need to get out of this. So you press second mode to get back to your main screen. Then we need to return to the matrix menu. So second matrix. Now we want to go over to math, like it says here. And you want to pick the option that says RREF, RREF, reduced row echelon form. I think it's faster if you actually press up, but you want the one that is RREF. So you'll notice there's one just like it above that has just ref. That's reduced row echelon, that's row echelon form. This is reduced row echelon form. If you do row echelon form, it's not going to do anything. It's going to just give you the same thing. You want to pick the reduced one because that's going to actually solve it for you. So make sure you pick RREF. All right, press enter there. You'll notice it puts it on your main screen. Now our very last thing we have to do is we have to tell the calculator which matrix do we want it to do RREF of. So we go matrix menu again. So again, just following my steps here. And pick matrix A. So the one that we've edited is the one we're going to want to do. So you just press enter. And then now that we're set up here, we should be able to press enter and it'll run the program and give us our solution. So it feels like a lot of steps. This is one of these things that after you've done this a few times, you get very, very fast at it. And you'll find that this is the absolute fastest way to solve a system. Like 100%. It really is. So now how do we read this? What does this mean? So this is the reduced row echelon form where it gets everything in these 9 boxes is going to always be either a 1 or a 0. You'll get nothing else here. And then the solution values are over here. So this is saying that 1x, no y's, no z's, is 0.5. So as we go to write this answer, I'm just going to write it up here. Our solution would be x is 0.5. Our y is 3. And then our z is negative 2.5. So that's our takeaway from that is we were able to figure out what do each of the things stand for. Okay, so let's look at the next one here. This says, what is the solution to this system of equations? So this one's awesome. They took it, they already wrote it as a matrix for us, so they did that work for us. We're actually in the step where all we need to do now is input this. So I'm going to just jump into my calculator, and I'm going to input it. So I don't care about this one anymore.
It says 4 on the first one, but there's no 4 in the first one. In the matrix, it says 4 instead of 3.
Ooh, yeah. So this probably... I guess that probably should be a 3. We'll see when we do it. Okay, so we'll go follow our steps exactly as before. So we're going to go matrix menu. And we're going to want to edit the one that we already had in there. And we're already in a 3 by 4. So we should be able to just go right through and just enter these numbers right over top. So you'll notice when you're here, if you press 2 and you press enter, it just replaces it. So the nice part about this is once you've done one, doing more of them is really simple. You're just going to re-enter all these values right over top. Okay, so we're looking pretty good there. Everything's in. Again, you can arrow around and you can double check that you got all the right things in there. Looking good. Okay, so from there, back to our steps. We need to quit out of this. So once you've got everything in, this is the step I notice people always forget. You have to quit out of this. So you go second mode to get back to your main screen. Now you need the calculator to solve this. So you're like, hey, I need to do RREF. So that's in the matrix menu. You go over to the math option. You pick RF. And then back to the matrix menu one last time to tell it to do, hey, do this to matrix A. And then we press enter. Okay, so our steps there are the same. Nothing's different stepwise. We do get a weird answer here. So I'm going to write this down, and we're going to kind of talk about what does this mean. So let me just copy this down into here so we can have it in our notes as to what are all these things saying. So we get a matrix that looks like that. Now, this one does not look like the last one we had. The last one we had diagonal ones and literally just said like, hey, X is this number, Y is this number, Z is this number. We do not have this here. Here we actually have a different kind of answer where this is like saying 1x minus 3z is equal to 4 and y is equal to 0. And then this bottom line here actually says 0 equals 0. Literally no variable equal to 0, which is true. This is a scenario that'll happen when your problem has infinite solutions. So this is where some of your lines are actually parallel, where they're actually crossing everywhere. And so on the back here, we're going to sort of break this down into the different possibilities. But this scenario is what's called an infinite solution problem. And so if you remember that, you saw that in Algebra 1. If you ended up with parallel lines, then you were going to have infinite values that were solutions to it. And so that can happen with these too. And that's really what you're looking at. So before we get to this last example here, on the very back page that's blank, I just want to lay out your three possibilities. So one possibility is, and this is the most common one for sure, is that you just get one solution. So one solution always looks like this. You're looking for diagonal ones. And then you can have any numbers here. These numbers literally don't matter at all because those are just your solutions. But if you ever see diagonal ones and everything else is zeros, that tells you that this problem has one solution, and that solution is x equals this number, y equals that number, z equals that number. That's the most common thing that happens is that scenario right there. You can also get what we just had happen a second ago, which is your infinite solutions. So what's going to happen on an infinite solution? The top two lines actually don't matter at all. What you're really looking for is if your bottom row is all zeros. So the top two lines can vary. They can be all kinds of different things. But if your bottom row is all zeros, that literally is saying that 0 equals 0, which it always does. And therefore, that's going to give you an infinite solution scenario. The third possibility is a no solution. So a no solution looks like this. So a no solution, kind of like the infinite solution, is going to have the top two lines will be various different things, but the bottom one is going to have something that's not true. It's going to have something like 0, 0, 0, and then a number here, like maybe like a 5. So this equation would now be saying that 0 equals 5. Most of you guys probably know 0 does not equal 5. So because you get a false equation in the bottom, that's the indicator that the problem has no solution. So we're going to see a variety of these as we kind of look at different things today. But that's the main thing. That's what we're looking for there is one of these three things is going to happen every time. And like I said, one solution is your most common output, where you just say, hey, x is this, y is this, z is this. But you can also get it where infinite or a no solution. And again, you're looking at that bottom row is your real indicator for those. Okay. Essentially, that's pretty much what I wanted to look at as far as those go. So let's stop that there.